Good morning, precalc fans. How are you on this fine, sunny Monday morning? I hope you had a great weekend. Thank you for getting all your quizzes and evaluations into me. I posted those grades on Progress Book. We did a nice job on that. You did a nice job. See, this is good for you guys because you guys can handle this. You can see that you can handle this material. You did a very good job. Let's continue on with trigonometric ideas. Once again, I hope everybody's doing well in your household. Hope everybody's staying illness free. Got some warm weather coming today, sunny warm weather. Go outside, do some things outside, clean out the flower beds for your parents, but also please do keep your social distancing out there. So once again, let's get ourselves back to normal. I miss not seeing you guys, I miss not having you guys around, I miss you guys. But it's our reality, so let's continue on. Today we're going to talk about trig ratios, and once again, this should be all review for us. This is the second time through the trigonometric ideas. You dealt with this in trig class, so this should be hopefully common things for you. I'm not going to go through this first part here, but we have our trig ratios. We have sine, cosine, tangent. And when you talk about the sine, and once again, this is very similar to what we did already. Length of leg opposite over the angle over length of the hypotenuse. The cosine is length of the leg adjacent to angle over the hypotenuse, length of the hypotenuse. And the tangent is length of the leg opposite over length of the leg adjacent. Okay, and once again, if I'm going too fast, hit your pause button. But these should be some things that you should already remember. We have sine, cosine, tangent. We have our trigonometric Indian. SOHCAHTOA, we have our trigonometric Indian that we can work with here. Once again, it's going to come back and you're going to use it quite a bit. SOHCAHTOA, or some old horse, kind of another horse taking oats away, whatever floats your boat. So this is our trigonometric ratios, opposite over hypotenuse, adjacent over hypotenuse, and opposite over adjacent. We have our reciprocal functions. We have the cosecant, which is CSC, that's a cosecant. This is 1 over the sine of theta. So it's the reciprocal of sine. The secant is 1 over the cosine of theta. And then the tangent is 1 over the tangent of theta. C goes with S, S goes with C. The codes don't match up with each other. Cosecant goes with sine, secant goes with the cosine. Now the main idea, the main thing that we dealt with respect to utilizing these ideas is the sine, cosine, tangent of some angle theta equal the sine, cosine, tangent of the reference angle. So the sine of theta is equal to the sine of theta reference. The cosine of theta is equal to the cosine of theta reference. And the tangent of theta is equal to tangent of theta reference. And theta reference is the reference angle, is what we just dealt with in the previous section. We also had our 30-60 and our 45-45 right triangles. Okay, remembering our values. We have 1 that goes across from the 30. We have 2 on the hypotenuse, and square root of 3 goes across from the 60. So you had 1, 2, and square root of 3. 45-45, we had 1, 1, and square root of 2. Okay, those are triangles that are commonly used in regards to dealing with these trig values. Let's see here. Across from the biggest side has to be the biggest angle, 90 degrees. 2 is the biggest value. Square root of 3 is approximately equal to 1.732. So that's going to be our middle angle across from middle side, and then the smallest angle and smallest side here. Up here we have 1, 1 square root of 2. This is approximately equal to 1.414. So what we're going to utilize is we're going to utilize this idea along with these ideas to be able to calculate values. I'm going to change this to 225 so we can look at it. Okay, tangent 225. Sine of 120 degrees, if you remember what we did. First we drew our picture. 120 degrees, which quadrant that's going to go into? That's exactly correct. It's going to go into quadrant number 2. So here's our quadrant number 2, our angle. We then completed our right triangle with our reference angle down to the x-axis. So we can have a nice little handy dandy right triangle. If this is 120 degrees, what's the measure of our reference angle? That's exactly correct. That is going to be 60 degrees. We have a right angle there, which means this angle has to be 30. Hopefully this is rekindling some fond memories of your trig classes. We did quite a few of these things here. Once we got that, we looked at our 30-60 right triangle. Across from the 30 is a 1. Hypotenuse is 2. Across from the 60 is square root of 3. Once we got that down, then we took a look. Do we have any negative signs that we have to worry about? Any side that goes to the left or goes downwards, we have to put a negative to it. If we take a look here, we have a negative 1. Square root of 3 goes up, so we don't have to worry about this. Think about this, once again, as an x and y axis. If I had a point right there, how would I signify that ordered pair? Well, that ordered pair would be a negative 1. That was my x value, and square root of 3, that is my y value. Because I have to go to the left, that's negative, up, square root of 3. So what I'm asked to find here is the sine of 120 degrees. Well, what's the sine to us defined as? Well, what I want to be able to come up with is exact values here. I don't want clickety-clack sine 120 degrees and give me 0.7071. I don't want that value there. I want the exact value. Well, sine is defined to us as opposite over a hypotenuse. So our side opposite is the square root of 3. Our hypotenuse is a value of 2. So that is the sine of 120 degrees. If I ask you to find the cosine of 120, that is adjacent over hypotenuse. That would be a negative 1 over 2. Our tangent of 120, opposite over adjacent, we have square root of 3 over negative 1, which we can simplify down to negative square root of 3. We can just take the negative 1 and throw it up top. And then anything reciprocal wise, we can just flip it over, flip it over, flip it over, flip it over. Remember to rationalize your denominator by multiplying top and bottom by the square root. A tangent. We'll take a look at the tangent of 225 degrees. Once again, let's draw our picture. 225 takes us all the way down into quadrant number 3. We make our right triangle. 225 degrees, what's the measure of our reference angle? That's correct, we have 45 degrees there. We have a right triangle, so this is 45. We have a 45, 45 right triangle, both legs are going to be 1s. And the hypotenuse would be square root of 2. We are going left and we are going downwards, so both of our sides have a negative sign here. So the tangent at 225 is defined to us as opposite over adjacent, so we have negative 1 over negative 1, which is a value of 1. If I found the sine of 225, sine is defined to us as opposite of our hypotenuse, so we have negative 1 over square root of 2. And once again, how do we rationalize this? We multiply top and bottom by square root of 2. So we have negative square root of 2 over a value of 2. Once again, I want exact values here. I don't want a decimal value that you clickety-clack through the calculator. I want exact values. Make sure you rationalize your denominator. Okay, draw a picture, throw in your 30/60s and your 45/45s. Terminal side of an angle contains the ordered pair 4, -3. So we have a terminal side of an angle goes through this point. What we want to be able to do is find the sine, cosine, and tangent of this angle. Well, what we are able to do is once again look at the reference angle. And let's take a look at sides. If we look at the top side here, the top side has a length of 4. This side right here, we go down 3, so this would be -3. And the hypotenuse, once again, we have a 3, 4, 5 triangle here, would be a value of 5. So we are looking at sine of theta, cosine of theta, tangent of theta. So we have our trigonometric Indian. Our sine is defined to us. This is our reference angle. This is our angle that we're talking about. But the reference angle here, the sine, cosine, tangent of theta is going to equal sine, cosine, tangent of theta reference. So these, we can just look at our reference angle. The sine is -3/5. The cosine is 4/5. And tangent is -3/4. Once again, these should be all things that should be reviewed for us. There should be nothing here that you sit there and go, ooh, I don't quite remember that. We can also take a look, I know I don't ask it. The secant, cosecant, and cotangent. To find my cosecant, I can just flip this over, so we have 5 over -3. So we have -5/3. We can flip the 5/4 to give me 5, or 4/5, give me 5/4. And then my tangent, I can flip to get my cotangent, -4/3. I know it's 4 over -3, but I could just sew my negative out front and I'm okay. Boom, 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 oh yeah. We take a look at the next one. The sine of theta is equal to 4/3 in quadrant number 2. Find the other trig ratios. Once again, we're going to draw our picture, draw a picture, draw a picture. In quadrant number 2, here's my angle theta. Here's my reference angle. The sine of this angle theta is equal to 4/3, which is also the sine of our theta reference. And once again, if I'm going too fast here, just hit pause and I'll shut up. And then you can catch back up again. Here's my reference angle, here's my theta. The sine of this angle is 4/5, which is opposite over hypotenuse. So my opposite is a value of 4. My hypotenuse is a value of 5. Once again, we have our Pythagorean triple. We have a 3, 4, 5 triangle. Make sure you check for any negatives. Well, this one goes to the left, so I need to make sure I get a negative sign with the 3. So we have the sine of theta, which we already know is 4/5. Cosine of theta, tangent of theta, which is a tangent of theta reference. Then the cosecant of theta, secant of theta, and cotangent of theta, which is also the secant, cosecant, cotangent of theta reference. So the cosine is defined to -3/5. Tangent, 4/-3 or -4/3. Cosecant, we just flip it over. Secant, we flip over, so we flip over 5/4. 5/-5/3, and then -3/4. Not a very difficult concept here. Once again, these are all reviews for us, review ideas for us. The cosecant of theta is equal to 10. We'll just draw the picture here. If it's given to us as just a value here, and it's a positive value, I'm just going to go quadrant 1 with this. If you're not given a quadrant and it's a positive value, you can just go quadrant number 1. Cosecant is reciprocal of 1/sine of theta. So this is hypotenuse over opposite. Well, I don't have a fraction here. Well, how can I create 10 as a fraction? Well, we can put this over a value of 1. So my hypotenuse is a value of 10, and my opposite is a value of 1. We can then use our good old buddy. We can use our good old buddy Pythagoras. Yeah, my good old buddy made it back into the picture. Our good old buddy Pythagoras here to find our third side. X squared plus 1 squared is equal to 10 squared. So I can subtract my 1 over. X squared is equal to 99. Take the square root. So we have square root of 99, which I could break down to square root of 9, square root of 11. So we have 3 square root of 11. And then you can find your other trig ratios there. Applications. We have triangle rat. Triangle rat is equal, and triangle rat, angle A is 61, angle T is a right angle, little r is 12. I want to calculate these other values. So once again, let's draw a picture of what we have here. We have triangle rat, and they say angle T is a right angle. So it does not matter which other two angles you put in there. Angle A is 61 degrees. Now if you remember back how we labeled a triangle, the side opposite the big letter is a small letter. So this is little r, this is little t, and this is little a. Your side opposite your big angle, your big A is your little a, big R, big T, little t. Little r they give us to be a value of 12, and that is feet. We want to find little t and little a. Well, if we find little t first, let's see here. This is 61 degrees. Let's find little a first. We'll do the easier one first. Our little a. What we have to ask ourselves is, which trig ratio relates our angle we know to the side we know and the side we want to find? That's a thinker. Well, if I take a look, I have the tangent of 61 degrees is equal to little a over little r. So we have a over r, which is a over 12. So we have the tangent of 61 is equal to a over 12. A over 12, that fraction bar means to divide. So what we're doing is we're trying to eliminate division. How do we get rid of division? we multiply, so we have A is equal to 12 tangent of 61 degrees. So in our calculator, make sure we're in a degree mode. We have 12 tangent of 61. Hopefully I'm in the degree mode. I want to check to make sure. Yes, I'm in my degree mode. So let's quit out of that. So I get 21.65. And that's feet. Boom, boom, boom. Yeah, that's what I'm talking about. Okay, that's what I'm talking about. 21.65 feet. Let's take a look at my other one, little t. I would go back. Yes, we can use our good old buddy Pythagoras to find little t, but the problem we run into is if I goofed up how we found little a, little t is going to be wrong also. So let's go back to our trig ratio. We have angle A, we have little r, little t, which trig ratio will relate this angle to these two sides. It's correct, cosine. So we have the cosine of 61 is equal to 12 over r. Whoopsie, how about over t? So to solve this, we need to multiply both sides by t now. So we have t times the cosine of 61 is equal to 12. I still have not solved for t. I have to get rid of the cosine of 61. I have multiplication there. So let's divide both sides by the cosine of 61. These will cancel, so t is equal to 12 divided by cosine of 61 degrees. So once again, going back to my calculator, we have 12 divided by cosine of 61. We get 24.75. And that's in feet. So we have 24, I hope I remembered that correctly, 24.75. So we have 24.75 feet. Once again, this should be all review for us. This should be nothing that's brand new to us. But hopefully we can work ourselves through this. I've posted a worksheet for you to work on. I'll post the solutions also to work on. Pretty much the same standard or same type of week this week as we did last week. We'll go through one other topic tomorrow. We'll combine all those things together on Wednesday in a review sheet. Thursday we will have a quiz that we'll be due on Friday, just like we did this week. So it's going to be the same type of things that we did in the last week. So if you have any questions about anything, feel free to comment me. I will try to respond back as soon as I can get back to them. But please do continue to work through the material that we're going through here. It's our new normal. Once again, I have faith in you guys. You guys have done a nice job already. Continue to do that. That's a growth mindset that we're going to be continuing to work on. We can do this. You can handle this material. Hopefully it's not too overbearing for us. This is sort of nice because this is all review stuff for us from trig class. Tomorrow we'll talk about inverse trig functions and arc trig functions, and we'll work through that tomorrow. Other than that, I have nothing else for you today. You go out and enjoy some sunny weather. Make sure you get some pre-calculus done and continue to work through the material that we're going to be working with. Other than that, I miss you guys. Wish you were back in class. We will see you tomorrow. Adios. Bye-bye.